So for the data analysis lab, I'm going to be analyzing all of our data in SPSS. And the first bit of data that we're going to analyze is our demographic information. So we'll need to run some descriptive stats to do that. So we're going to go to Analyze, Descriptive Stats, Frequencies, and we're going to move all of our demographics over. Go. And then I'm going to go to charts and I'm going to mark histograms and show normal curve, continue, and then I'm going to click OK, and my output will pull up and there will be my histograms for all of my demographics with my normal curve superimposed. I'm going to minimize that. Okay, and then I'm going to just keep an eye on that information, remember where it is on my output because I'm going to need that for my method section. So for our inferential analysis, we're going to run our statistical test, and so for most of us it's going to be a Pearson R, so that's what we're going to do here. So in order to run a Pearson R, you're going to go to Analyze, Regression, Linear, and you are going to pull over those composite variables. And you're going to go to Statistics, and you're going to ask for the R-squared changed and the descriptives. You're going to click OK, and then we're going to click OK. And we're going to scroll down and take a look at our model summary. So this is not their actual data. This was, I used just shortened data. I took a bunch of items out just to make it quick so I could do this video. But if this was their actual data, then it would be saying that their Pearson R correlation coefficient is 0.048, that their R square, which is their effect size, is 0.002, and it is showing that the significance level is 0.860. So in order for me to reject HO and support my hypothesis, this significance level would need to be at 0.05 or lower. When you're writing your sentences in statistical form, you're going to use the degrees of freedom residual in the parentheses. So you're going to need to find your Pearson R. You're just going to want to check that with your group members. And if it's not the exact same correlation coefficient, then you will want to figure out where the error is. So errors usually come from mistakes in data entry like reverse coding or composite variable formulas. So you'll need to locate the source of the error, and you can try these following steps to help you do that. If you do have an error. But I would say if like 3 out of 5 of your group members have the same correlation coefficients and everyone did it individually, then they're probably correct. But anyways, if you guys don't match up on your outputs, then you'll want to do this section C. But we're going to move on to section D. So you're going to need to get descriptive statistics and histograms for each of your variables. To do that, you're going to go to Analyze, Descriptives, Frequencies, and then you're going to get your demographics out of the box, and you're going to want to put both of your composite variables in the box. And then once you do that, you're going to go to statistics and make sure you have the mean, the standard deviation. What else do we need here? The minimum and the maximum. The variance. Okay, that should be good. And then you are going to click continue. Then you're going to go to charts, and you're going to make sure histograms with normal curve on histogram is checked. Click continue, click OK. And there is your histogram for your variables. You'll need that. And all your means and standard deviations for your two variables here. Your n, you'll be needing all of this as well. Okay, so you're going to find the histograms on your output and then screen them for normality and report those findings on your final paper. So this variable here looks pretty normally distributed, so I would say that meets the assumption of normality. This one here seems to be a little bit skewed to the left. So I would say that one doesn't meet the assumption of normality, but this again is not their real data. But anyways, that's how you screen for normality to see if your data takes the shape of a curve, how it compares to this superimposed normal curve. Okay, and then you are going to need to create a scatter plot. So you're going to go to, I'm going to minimize that. Okay, you're going to go to graphs and chart builder, and then come down here to the choose from box and click scatter dot. And then the second one on the top row from the left is titled simple scatter with fit line, so you can just click and drag that. And then you're going to grab your composite variables and put them one on the x-axis and one on the y-axis. And then this is not going to be how your scatter plot actually looks. This is just generic data. It's not the real deal. So don't worry if you get some weird looking scatter plot there. So then you're just going to click OK. And that scatter plot's going to show up on your output. And here is the fit line. So you want to try to meet the assumption of homoscedasticity, which is to have an equal number of data points above and below this fit line or regression line here. And so if this were real data, I would say this one did not really meet it. There was a lot of data on one side of this fit line here. Okay, so that is how you make a scatter plot. And then the next step is to do a Cronbach Alpha. So for a Cronbach Alpha, you're going to go to Analyze, Scale, Reliability Analysis, and then you are going to transfer. Let me clear this out real quick. Okay, so when your reliability analysis box pops up, you're going to transfer all the regular and reverse coded items for one of your variables into the items box over here. So not the irrelevant items, but all of your regular and reverse coded for one of your items, or one of your variables, I'm sorry. So I've done that here, and then the next step is to make sure that the model is set at alpha, which it is. Click statistics, and then make sure that these three boxes, item, scale, and scale if item deleted, are all checked. And then you're going to click continue. Okay. And your Cronbach Alpha will appear for that variable. So this one says it's a 0.44. So if this were real data, that would fall under the unacceptable, which just means like unacceptable for publication, basically, but not great for your reliability. So that would just mean that it didn't really measure what you were intending to measure in the same way every time. So maybe people interpreted the questions differently, for example, or the items, what they were asking. And then you can scroll down here to the item total statistics, and it will tell you what your significance level would be if you were to, what your Cronbach Alpha would be if you were to delete the item. So would it get more reliable into this 0.9 or higher range, or would it get less reliable? So it looks like if we were to delete the SR5, our Cronbach Alpha would go up to a 0.768. So that would at least put it into the acceptable range. So that one question, it's probably because I didn't actually reverse code it. I should have, but I didn't. And so it didn't correlate with the other questions. So if that was deleted, then this variable, the items that were measuring this variable would have been more reliable, is what this is telling us. Okay, so then you are going to repeat this process again for your second variable. So you're going to go to Analyze, Scale, Reliability Analysis, and you're going to clear out all of your previous items, and then you're going to put in your other regular and reverse coded items from your other variable, skipping the irrelevant. And I think that's good. Make sure the model's set at alpha. Statistics, all three descriptives should be set. Click continue. Click OK. And then you will find your Cronbach Alpha for that variable. Okay, so after you have done your reliability analysis, then you're going to just go back and grab that R-square value from your original Pearson R statistical analysis. So here it is in that model summary. So your R-square was 0.002, so you would multiply that by 100 and write down your percentage. And so then an R-square value that is greater than 0.25 or 25%, you would describe as a large effect size in your paper. So the next step is to save all the data as a .sav file and the output as a .pdf file. So you could save this output. Oops. You could save this output by going to File, Export, Type, PDF, and then click OK. And it will export it as a PDF. You'll need to submit that as well as your data file to Canvas. Okay. And I'm going to save it as a .spv as well. And then I'm going to save my data set. It's already saved as dataset.save, so I'll just update that. And then you will submit those files to Canvas, and that is it for this lab. Thank you for listening. Talk to you next time.